Number 27, what is the value of the equilibrium constant expression for the change H2O liquid yields H2O gas at 30 degrees Celsius? And then they say see Appendix E. So I pulled up the Appendix E over here, and let's just rewrite this a little bit better, right? So we have H2O liquid, which comes to equilibrium with H2O gas. Now, they want the equilibrium constant expression. Remember, that's a K value, right? And they actually want the value of it, so they want an actual number. But this kind of comes from the formula. Remember how we make an equilibrium constant expression, right? It's products over reactants. It's this formula right here. Now, maybe I can just bring this down a little bit, and maybe I will put it, I guess I'll put it right here. Right, it's the pressure of the products divided by the pressure of the reactants, but only aqueous and gases are allowed. Now look here, guys, right? I have H2O, but that's a liquid. Am I allowed to use this in my Kp expression? No. So don't even bother. Get rid of the whole thing. But this one, this is a gas, right? I see the G there, so I'm going to, take that into consideration. So in this case, that Kp value would be equal to the pressure of the H2O. This is the product. And since there was only one here, right, I can raise this to the first, but it doesn't matter, all right? Now, divided by, I'm not using any reactant value, so I just use a placeholder as 1. And then the pressure of H2O divided by 1 is just the pressure of H2O. Okay, so we're getting somewhere, right? Here's how we're going to find that value. The Kp is just going to be the pressure of H2O. Now, that's where we got to go to Appendix E. So I'm going to look over here. They told me that it's at 30 degrees Celsius. So here's 30. And I'm going to take the vapor pressure of torr. So it seems like this is 31.8 torr. Okay, but there is a rule here. If you're talking about Kp values, it can't be in torr. It has to be in ATM. So I wrote down the conversion between the ATM conversion factor and the torr conversion factor. 1 ATM equals 760 torr. So in order to make this work, I just have to convert the 31.8 into torr, right? So I'll just say 31.8, that's what I got, torr. Times by a ratio, put the torr on the bottom, put the ATM up on the top, and then just know that it's 1 ATM for every 760 torr. Seems like we're dividing here. All you got to do is just divide 31.8 divided by 760. And I'll keep it, I guess, at 2 sig figs. Doesn't really matter to me. Maybe I'll do 3 sig figs because there was 3 here. So maybe I'll say 0.0418. And that's now an ATM. That's the number that goes here. And the Kp equals that pressure value. So the Kp would just equal 0.0418. You do not include units for the Kp. Kps are just used as ratios. So any ratio, doesn't matter what it is, it's unit-less. It has no units. So even though this is the pressure of the PH2O, there is no units for Kp. And that's it. Hopefully this helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel. That will help us out. And I will see you all later. Bye-bye.